So get this, the algorithm that could double your EV's battery life. That sounds pretty incredible, right? Well, today we're going to dive into a breakthrough that could totally change the electric vehicles we drive. And here's the kicker. It's not some new wonder material or a gigantic battery. Nope, it's a simple, really elegant piece of code.
So let's start with this question. What if the secret to a longer-lasting EV isn't a bigger battery, but a smarter one? I mean, think about it. Whenever we talk about making EVs better, the conversation always goes to bigger batteries, right? More range, faster charging. But what if we've all been looking in the wrong place? What if we've been so obsessed with the hardware that we've completely overlooked a much smarter software solution hiding in plain sight?
Okay, so to really get this new approach, we've got to talk about the EV battery's big stress problem. There's this kind of hidden enemy lurking inside every single EV battery out there. You see, it's not just about running out of juice. The real enemy, the thing that's killing your battery's lifespan, is stress. Every single time you get behind the wheel, your battery is getting stressed out. And I'm not talking about its charge level. I'm talking about how you're using it. This stress is what slowly but surely chews away at your battery, making it weaker and weaker over time. So what kind of stuff is stressing it out? Well, it's all the things we do when we drive. Mashing the accelerator at a green light, slamming on the brakes, needing a sudden burst of power to pass someone. All of that. Researchers have a name for it: dynamic load stress. Basically, every time you do that, you're sending these nasty jolts through the battery, causing these huge, damaging spikes in the electrical current. So the big question is, how do you protect the battery from all that stress? Well, you give it a little helper, a powerful assistant. Let's take a look at the hardware that makes this whole thing possible. And here's the solution: this hybrid duo. Think of your main lithium-ion battery as the marathon runner. It's got all the endurance, all the long-term energy. But then you pair it with a supercapacitor. And that thing, that's your sprinter. It's built for those super short, crazy powerful bursts of energy. So it steps in and handles all the high-stress, high-power demands, taking the load off the main battery. It's a perfect team. Together, they're called a hybrid energy storage system. And get this isn't just some theory cooked up in a lab. Nope. Researchers are actually building this tech into real cars. You're looking at a converted vehicle right here that was used to run the simulations and prove that, yes, this whole concept actually works in the real world. But, having the cool hardware is only half the battle. You've got to have some smart software to control it. And the way everyone's been doing it, well, let's just say the old way of thinking has a pretty big flaw. This standard rulebook is called the Power Follower Strategy, or PF for short. And look, it's the industry standard for a reason. It's pretty simple, it's robust, and a lot of people use it. All it really does is tell the supercapacitor, hey, jump in and help out whenever the power demand hits a certain point. But here is its big, fatal flaw. It creates these really abrupt, jerky power changes. It's like flooring the gas and then immediately slamming on the brakes, but for your battery's power. It's just so sudden. And those super steep changes in current, that's exactly the kind of stress we were trying to get rid of in the first place. Aha, but this is where the real genius comes in. This is the new, smoother strategy. Researchers came up with a really simple but incredibly powerful update to that old clunky rulebook. And this analogy just makes it all click. The old way? It was like a harsh flick-on, flick-off light switch. Clunk, on. Clunk, off. That's what caused those jolts. But this new, refined strategy, it's like a smooth dimmer switch. It just gently and gradually ramps the power up and down. So much better. So how does it do it? Well, the secret sauce is this really elegant piece of math called an exponential smoothing function. It's a simple algorithm that does exactly what we want. It gradually ramps power up or down, completely avoiding those nasty spikes. And the best part, the absolute beauty of it, is how simple it is. There's just one little tuning knob, this alpha factor, that you use to control how smooth the ramp is. That's it. No crazy AI, no massive supercomputer needed, just smart math. Okay, so an idea is only as good as its results, right? Theory is great, but does it actually work? Let's see what happened when they put this strategy to work.
So the team set up a little experiment, basically a head-to-head competition. They put 3 methods in the ring. In one corner, you've got the old power follower strategy. In another, a different popular method called frequency split. And in the third corner, our new contender, the refined power follower algorithm. They threw the exact same stressful driving conditions at all 3 to see which one would come out on top. And wow, the results were not subtle, they were immediate and crystal clear. Take a look at this. This shows the biggest jolt, the maximum spike of current that the battery had to handle. And you can see it right there. Our refined strategy had the lowest peak current, by far. That means way less immediate strain on the battery than either of the other guys.
But honestly, the number that just blew me away is this one, 18.73%. That's how much the new algorithm reduced the overall battery stress. That's the day in, day out wear and tear, compared to the old industry standard. Almost 19%. That is a huge deal, a massive improvement for battery health. And it's all from a simple software tweak. Incredible. And if you look at all the data together, the story is the same. The refined PF strategy just wins. It's the champion on the two things that matter most for your battery's health: lowest peak current and lowest overall stress. It hits this perfect sweet spot, you know? It gives you that super smooth operation without losing any of its power to protect the battery from a heavy workload.
So why does it work so much better? Well, let's go back to that traffic idea. The old way, it was terrible at traffic control. It created these massive traffic jams of electrical current, with everything piling up in one spot and causing a ton of stress. But this new method, it's like the world's best traffic controller. It just smoothly and evenly distributes all the current, so you never get those unhealthy, stressful pileups. It's just a much healthier way to operate, long term.
Okay, let's bring this all home. The technical stuff is cool, for sure, but what does a nearly 19% drop in battery stress actually mean for you, for the person who owns and drives an EV?
Honestly, it means everything. It's a total game changer. Less stress means a longer-lasting battery. I'm not talking a little bit longer, I mean potentially much longer. And that ripples out, right? It means better vehicle efficiency, it means lower costs for you because you can put off that crazy expensive battery replacement. And on a bigger scale, it means more sustainable transportation for all of us. And that really brings us to the main point, the big takeaway from all of this. Smarter, not just bigger, is the future of EV batteries. The future isn't just going to be about cramming bigger and bigger batteries into cars. It's going to be about using brilliant software to squeeze every last drop of performance and life out of the hardware we've already got. So that leaves us with a pretty fascinating question to chew on. As our cars get more and more powerful and we demand more from them, are we heading toward a future where the smartest algorithms actually become more important than the biggest batteries? Will the code be more valuable than the cells? Something to think about.